Hello, good evening everyone. My name is Syed Amir Muhyiddin. I'm working in NetSwap solution as a technical consultant. Today we are going to discuss on Nexus OS and using the Nexus switches into leaf and spine architecture. So let's start with our agenda first. In our agenda today we have Nexus switches and different models and deployment methods, what we're going to be deploying these Nexus switches, and what are the challenges of previous technologies such as 3-tier architecture, and why we are migrating from 3-tier to the latest spine and leaf architecture. What are the benefits of moving from the existing architecture to the new architecture, and what are the licensing packages we have and different concepts we have while considering this spine and leaf architecture, and what is the management methods we are using to manage this spine and leaf architecture as well as the Nexus latest models. So let's discuss one by one all these topics. So first, when we're going to start with the Nexus switches. Nexus switches are the most advanced switches which are predefinedly designed to meet the requirements of data center, which give you the high availability feature, high performance, infrastructure scalability, operation continuity. All these features will be embedded into the Nexus switches, and these switches comes with two different flavors of operating system. One is your NexOS, another one will be your ACI, and both these operating system can be run on the top of the same hardware, and the hardware is designed to support both the operating system. So when you go into the catalog of Nexus, you have the series starting from 1000 model to the 9000 model, and 9000 is the latest portfolio of the Cisco, where you will get all these features. You can use this hardware along with your old hardware, that is 2000 and 3000 series, and you can extend the Nexus spine into their using your FEX modules. So let's discuss what are the different architectures where we can use to deploy this Nexus switches. So traditionally, while we go into the previous versions of deployment, we have three-tier architecture. So whoever is working in this networking field from last 5 to 10 years, you will be having this architecture. You will be working on this architecture. So this architecture is prima facie designed to suit enterprise as well as data center in the previous days. Now, at the advent of large number of devices and multiple users are using multiple phones, multiple devices, so the traffic at the access layer of this architecture is increasing, and that is whenever the user want to send more number of traffic, it is causing the delay in the network. For that, we have migrated our network to the new technology that is known as your spine and leaf technology. So spine and leaf is also called as clause architecture. Clause is not an acronym, but it is just like Charles Clause has discovered this technology, that's why it's called a clause architecture. So your next the spine and leaf is also called as clause architecture, but it is of here what you can see in the difference between the 3-tier architecture and the spine and leaf architecture is, in the 3-tier architecture you have dedicated three different levels where you can execute three different performances. In access layer basically used to send the get the queries and get the replies from your servers to the core. So basically it is used to design basic level of switching, and then the aggregation or the distribution layer of the 3-tier architecture is basically used for quality of service and the basic routing stuffs, and the core is basically used to control the control plane of data and management of the data. So that is the three levels we have in the 3-tier architecture. But we consider about when we go through this spine and leaf architecture, you will see your core and aggregation is merged into the only one one level that is known as your spine level. So spine is the mind of your architecture, and leaf is just like a branches where you are extending your spine will be giving the orders and leaf will be receiving the orders. And here the bandwidth, the major concern why we move from your three-tier architecture to the spine and leaf architecture is the bandwidth concerns. So when you consider the three-tier architecture here, so here in this architecture is not a full mesh architecture, you can see. So if you have a server connected to two different switches, at that time whenever there is a loop formation into your network, STP spinning tree protocol will come into play and try to avoid the loop. For that thing, the redundancy is maintained in the active and passive manner, not in the active and active manner. In that case, one port will be blocked, one port will be active unless and until there is some failure of link or failure of device. That link will become active, and the other link will go down. So for that reason, we are losing one port as well as the bandwidth efficiency in this architecture. While we consider about the spine and leaf architecture, we don't have that kind of scenario over here. Here all the links are active all time. Bandwidth is they here the spine and leaf use ECMP, equal cost multipath routing protocol to load balance the traffic between the different links. And here the leaf will select the lowest cost value, whichever the link is less, doesn't have much traffic on that link. It will select that link to traverse the traffic from your leaf to the spine. So when we see about three-tier architecture and your spine and leaf, here the maximum count the endpoint has to hop, the endpoint traffic has to hop is 2, because the endpoint will send the traffic to the leaf, and then leaf will take the traffic and move it, supply it to the spine. Okay, so only 2 hops will be the traffic will be traversing. Well, compared to three-tier architecture, it can be traveled across the access, segregation and core layer differently. So it will here we don't have much delays. And then we consider about in the IPMF network, multimedia fabric network. Here in that the sources are multicast based. Sources are multicast based sources. So at that time, what we are going to have is the latency is the major issue in the IPMF network. But as you see, all the networks of the IPMF network are having high bandwidth endpoints, because they are they are carrying the multimedia traffic, not the unicast traffic, so that there is a much more chances of congestion in the IPMF network. For that, there was one of the drawback, the challenge was to cover was bandwidth requirement. So for that purpose, what we have did is we have come across one more concept, that is non-blocking multicast forwarding, NBM kind of rule. What it does, it will act on the next OS operating system. It is a process which act on the next operating system, which makes your routing intelligent, which will fix your ECMP and multicasting kind of scenarios, and it will forward your links traffic very fastly using the NBM process. So that's how the multicasting issues were resolved using your NBM process. So next, going to our next slide, that is the licensing packages. What are different kind of licenses we have? So there are 3 types of licenses we have. One is essential, second one is advantage, and third one is premium. So essential license covers your basic fabric management features, your routing and switching features, and your telemetry features. When we consider about the fabric management features, it includes your DCNM and PTP features. Fabric service features such as ICAM, ITD, and IP fabric for multimedia non-blocking multicast, and routing and switching features just like different protocol support of layer 3, that is BGP, IGRP, GRE, PIM, SSM, Vxlan, and different kind of other protocols also. So telemetry feature is basically used to collect the data or the logs from the switch sensors to record that logs into the manager, so that the logs will be collected and analytics will be used on the top of that, and it will give you the log results at the Dcna or NMS tool. So telemetry will be used to get the logs from your switches. When we think about the second level or second type of your licensing package is Advantage. In this Advantage package, you will have all the features of Essential. Along with that, you have few advanced features such as load balancing, DCI, or overlaid features, your MVPN features, your multi-site EVPN features, and MPLS features. All these features comes across when we are going to have an Advantage as a license package. And third one was the Premier package. In this Premier package includes the essential package as well as your Advantage package. Along with that, we have few things such as your NIA, Network Insight Advisor. Then we have Network Insight for Resources and Network Assurance Engine. So NIA, Network Insight Advisor, it will advise you what are the current updates your switch is running, and what could be your current update, what are the updates you are missing, and what are the security patches you are missing. So this tool will give you all the insight about what are the configuration you are pending on. So this will give you the advice. Second thing is resources. Network Insight Resources. NIR is a tool which give you the resource information, how much memory utilization is there, how much your RAM utilization is there, what is your temperature of your system. All this internal resource information is provided by Network Insight Resources. And third one is Network Assurance Engine. This will give you all the assurances which is required to accommodate your assurance and auditing part and reporting part. So now we'll discuss about overlay, underlay, and Vxlan. What is an overlay network? Overlay, let's start with the underlay network, because before going to the overlay, underlay, you have to understand the underlay network. Underlay is something where your physical connectivity matters, your L1 and L2 level of connectivity, how your leaf switches are communicating with your spine switches, the connectivity between your spine and leaf, which are the cables they are using, which are the underlay protocol, such as your unicasting protocol of OSPF, MPBGP, COOP, EIGRP, etc. These protocols are used to establish the connection between your spine and your leaf, so that they will be able to establish a communication and reachability among your leaf and spine switches. So this is how we make an underlay network. Overlay network is a protocol. Overlay network is a network which is created on the top of your underlay network. For an example, Vxlan, or you will make GRE connections or MVPN connections. These are the few examples of creating an overlay network. So the third keyword is Vxlan. What is an Vxlan? Vxlan is a terminology or the extension of your VLAN concept. So while we consider about the VLAN, what are the limitation of VLAN? So first of all, understand what is VLAN. VLAN is something here will divide your large domain into small domains. So for an example, you have a system and it is connected to VLAN 10. Then the traffic which is coming to VLAN 10 should be segregated from all the other network traffic. For dividing the large domain into the small domain, we create a VLAN. Then Vxlan is the extension of VLAN, because VLAN has one disadvantage. I mean, this VLAN has one of the the challenge, that is we can make only 4096 VLANs. Now in the data center environment, you have to make more number of VLANs, because there are a lot of customers are there who, for an example, you are running a cloud data center. In a cloud data center, you will be having thousands of customers into your environment, and you have to create a different VLAN for each customer. For that reason, we have moved to the Vxlan. So as you have understood the concept of Vxlan, so just me repeat it once again. The Vxlan. Vxlan is a virtual extensible LAN, which is just like the extension of VLAN. We are moving your moving your layer 2 dependencies on the layer 3 dependencies. We are binding the VNIs to your bridge domains and bridge domains to VRF. Here the layer 2 traffic will be taken care by your bridge domain, and layer 3 traffic will be taken care by your VRFs. Okay, so this is all about the Vxlan concept. Okay, next slide. We are going to the next slide here. Okay, the next concept is DCNM. So what is an DCNM? DCNM is a data center network manager to manage all the switches of your data center. We don't have to log into each switch and configure, go to the using your console cable, connect your console cable and log in with your putty and do the configuration. That's not required, because in the data center we have lot of devices, and lot of devices managing through the putty or remote sessions is not an easy task. So Cisco comes up with a this data center manager which helps all the Nexus devices to be monitored, managed and configured from a single centralized place. So for that we use data center network manager. In the data center network manager is a template based installation. You don't have to go learn all the CLIs and all. It will give you the complete template. Just fill the related information into the template and run your deployment, and that's it. When you do all the fulfill all the requirements and all the details into your template, at that time you will be able to run your query, and the auto configuration will be played on the backside, and that configuration will be compared with your existing configuration. If everything goes well, the configuration is pushed and your network will be deployed. So let's see how it is done. So automation, it supports three features: automation, visibility and consistency. The automation is a part, as I told you, it supports your template based installation. Just fill the template and your code will be automatically created, and compare that code with your recommended code and deploy the configuration. Second thing it supports is visibility. So you have 20, 30, 40, 50 Nexus switches. So at that time it will give all the interfaces configured on each switch, what is the type of traffic flowing on each interfaces, and which interface is up, which interface is down, what is configured on each interfaces. You can easily see by using your DCNN software. And third thing is consistency. Consistency is nothing but it will compare your existing configuration with your recommended configuration. So the configuration always should be consistent throughout your network. It should not be like you are deploying something and something is configured on the device. So that thing should not be happen. So DCNM also take care about the consistent configuration inside your entire network. So let's move to another slide. As I told you, what will happen with the template based installation? Well, it will be easy to deploy, as you just need to enter the information into a template. And profile based configuration, it means you are creating the configuration based on a profile. If you remove some of the things from your profile, it will affect only a single profile. It will not go into all profiles. So the profile based installation gives you the flexibility to edit, modify a particular profile, not the complete network. And third thing is increases your visibility. So as you can see all the ports, all the devices into your network, it increases the visibility, and that visibility will be helpful while troubleshooting if something goes wrong. The working flow of DCNM. So DCNM has four phases. First is provisioning phase, where you will provision your fabric. Second is your building phase. In that building phase, you will select a fabric or create a fabric. If you already have a fabric, then you have to select that fabric. If you don't have the fabric, you have to create a fabric. The third thing is you have to create a network. In the network, you will define all the IP address, subnet mask, and your network mask, all the details. By using that information, you will create a network. Once you created a network, then click on the deploy network. That will deploy your entire network and fabric inside your DCN. Prerequisite. What are the prerequisites for configuring DCNM on virtual machine is you should have vCenter server above 5.5 version. You should have VMware EXSI 6.0 and above. You should have at least 2 port groups, and you should have to allocate 4 CPUs, 12 GB RAM and 200 GB of hard disk to your virtual machines. And you should of course you should have virtual client to configure your DCNM or OVE. Next, once you configured everything on your DCNM, then the first window will open is your login window. In that window, you have to enter username and password that you have given during the time of installation. So second, once you logged in, you will get a dashboard page. On the dashboard page, on the left hand side, you will get menus, and right hand side, you will get the contents. So next tab will be your control tab. In the control tab, you will be having a create fabric option. Once you click on the create fabric option, you have to give the name to your fabric. You have to select the template which you are going to configure on the fabric, and then you have to enter the details in the general, advanced, resource, manageability and bootstrap settings. Just like what are the BGP ASN number you want to configure, and what is the protocol you want to use for fabric numbering, and what is the intermediary protocol or the underlay protocol you want to select, what is the replication mode you want to select, what is the multicasting group you want to assign. All the details you have to fill it, and this is template, and it will be having all the details previously. It fed with the this template will be having all the details, but you have to change according to your requirement. Next is discovery process. Here, for discovering all the existing switches or newly configured switches, just need to enter you need to enter one of the seed IP of the switch which is configured, and then you have to enter username and password of the switch. Then click on start discovery process. The process will go on, and once it is completed, you will get all the switches which are close to your seed IP. So select your switches which you want to move into your fabric. Once you select all the switches, then your network diagram will be created, your topology will be created. Then you need to change the roles. If you want to change the roles, for an example, you have selected some of these leaves as a spine and spine as a leaf, just assign a role to a particular switch that is changeable. And once you have created a topology, you have assigned the roles. Then if you want to make a VPC pairing, so it is very simple over here. Just right click on the switch and click on VPC pairing. So it will give you some of the options like to which switch you want to make the next VPC pair. Just select the VPC pair and your pairing is done. So once all the configuration is completely successful, then you are ready to make an production network, and your network is ready to get onto the policy based routing. So next, this is the end of the slide, and if you have any questions, you can reach me at amir@netsoftit.de, and let me know if you have any questions. This is a quick review on the NexOS, Nexus Switches and DCNM software, and I'm open for next session. Whenever it's possible, I can make a next session in detail about discussing what is the overall features of DCNM. Thank you. Meet you again.